Okay, awesome guys. Our recording is up and running for your benefit. So as a way of introduction of today's lesson, it is going to be a continuation of a lesson which we had previously. And I think we had a session that covered counting principles and that counted as part 1. So today we'll be looking at part 2 of probability, specifically counting principle. And if all things go well, this might be the last at least lesson on counting principle. So maybe as a way of just taking you briefly over what we went through last time, is we started off with this example, guys, which you can see on your screen, where we have 3 t-shirts and 4 trousers. And the question was, how many combination or outfits can we make out of, 3 t-shirts and 4 trousers that have different colors? That is where we started laying the foundation for counting principle. And I defined what counting principle is. And most importantly, guys, which is what we referred to a lot on the first part of this lesson, was what the fundamental counting principle states, or at least that theorem. And this here, which we wrote, which is what the fundamental principle or the counting principle states, is very important for our understanding of what we do thereafter. So to understand this exercise, guys, where we have 3 t-shirts and 4 trousers, what we did was to draw a table where at the top we have the t-shirts, blue, green, and white. Yep, we chose those colors. The brownish trouser, we chose to say it's white, because myself and the people who were in the lesson, I'm not sure if we know what color that is. But anyway, then we went to the shorts and we named them as blue, white, green, and red. And we made different combinations. And all what was happening here, guys, if you remember, we're just looking at the t-shirt and the short. So blue t-shirt, blue short, and so on. Blue t-shirt, white short, blue t-shirt, green short. I'm looking at the second row, essentially, this row, guys. So the B is going down for the blue t-shirt, and the other variables that are changing on the right here, these are for the shorts. And what we found out was that if you have 3 t-shirts and 4 trousers, guess what, guys? You can make up 12 outfits. Is that not superb? So with 3 t-shirts and 4 trousers, you can have 12 different looks. And people are going to start believing your wardrobe is very much packed. So mathematics is beautiful, guys. And then we said, but look, the problem is that you might find yourself having 5 t-shirts and 8 trousers. So drawing the timetable or drawing that table is not sustainable. So how many unique outfits can we make with 5 t-shirts and 8 trousers? And this is where we had to now, guys, use the fundamental theorem or the counting principles theorem, what it states. So we have 5 choices of t-shirts and 8 choices of trousers. And all what we do, if you go and read what it states, we will multiply the number of options that we have for each and every option that is there. So it's 8 times 5, which gives us 40 different outfits. So with 5 trousers and 8, so with 5 t-shirts and 8 trousers, you can form 40 unique outfits. So it means if you were to take pictures and you were busy flipping your outfits around, you would get 40 pictures where you look different in every picture from the previous one. Is that not beautiful, guys? Especially for the content creators. You should go and teach them and say, do you know that if you have 10 t-shirts and 15 trousers, you can make 150 outfits? They'll be blown away, isn't it, guys? That is what we do. And then example 3, we also did something similar, guys. And then all what we did was we added sneakers. So on top of the t-shirts and the trousers, you have 3 sneakers. And how we work this problem is we have options On the trousers, we have options. On the t-shirts, we have options. On the sneakers, and guess what? With 3 sneakers, 5 t-shirts, and 8 trousers, we can make up 120 outfits. So that is the power of this, guys. Very important. And then example number 4, we did the same. We said, okay, what if you have 5 t-shirts, 8 trousers, 3 different sneakers, and 4 caps? How many unique outfits can we make? So if you look carefully, we have a choice from 5, from 8, from 3, from 4. And according to the counting principle, we need to multiply the choices that we have. And when we multiply these, what we get is 480 different unique outfits. So this means, guys, when you have 5 t-shirts, 8 trousers, 3 sneakers, and 4 caps, if you combine these clothes differently, you can take 480 pictures, and in every picture, you will look different. Is that not wonderful? Imagine 5 t-shirts, 8 trousers, 3 sneakers, 4 caps. You can take 480 pictures, and in every picture, you will not look like the previous picture. There will be something different. And there it goes for you guys who are content creators. Do the maths and say, okay, maybe I only need like 10 t-shirts and 10 trousers and 5 sneakers and 12 caps. And I'm going to repeat the outfit that I'm wearing now in 7 weeks' time because I know maths. Anyway, guys, and then we went into these kind of problems where we are required to formulate or to state how many combinations can we make if we are required to put in a 4-digit PIN, and most importantly, we cannot be repeated. We cannot repeat any digit. And this today will be our foundation, guys, very important. So if you think carefully, if you are trying to form a PIN which has 4 numbers, you'll obviously choose from 10 numbers, from 0 up to 9, that is 10 numbers. So if they say you can't repeat any number, the first number you can choose from 10 numbers, what you choose that sits there. The second number you will choose from 9 because you have chosen 1. The third number you'll choose from 8 because you have chosen 2 numbers. The fourth number you will choose from 7 because you have chosen 3 numbers. And how do we get, how many pins can we make if the law says we can't repeat numbers? We can make 10 times 9 times 8 times 7 combinations or number of pins, which is what we get, guys. What we got was 5,040 unique pins. If they say we can't repeat any number here. Okay, guys, let's have a look at now example number 6, just briefly. On example 6, we are required to make a pin, and I really advise that you guys check the previous lesson to fully understand this. Example 6, which we did on the previous lesson, we were required to make a pin that has 4 digits. And we are asked how many combinations of pins can be made if we are allowed to repeat 1 digit. So we are allowed to only repeat 1 number. So think of it, guys, what happens here. So it means the first number, when we are doing our 4-digit pin, we are going to choose from 10 numbers. What are the 10 numbers? It is 0 to 9. 0 to 9, that is 10 numbers. And the second number, or another number within this pin, will also be chosen from 10 numbers, because we can repeat the number that we even choose as the first digit. And then the third one, we only have an option of choosing from 9 and then subsequently from 8. And what I was doing here in purple was just to show you that what we can do is we can choose the first and the third number as being the same and so on. But we found that if we are allowed to repeat 1 digit in our 4-digit pin, we will end up having 7,200 different combinations that can be made. Right. Let's jump to example 7, where we are required to, we're allowed to repeat two numbers. So that is why I have 10, 10, 10, meaning I can happen to choose the same number. Let's say I choose 1, I can repeat 1, that is repeating it twice. And then the one which is here, I'm going to choose from 9 numbers as an example. So that is why we have 10, 10, 10. And then when you multiply that, that should give you 9,000 different combinations that you can make. And then let's have a look at the last question, guys. We are still required to formulate the PIN, but we are allowed to repeat all digits. So if you think carefully, once they allow you to repeat all digits, what you can do is you can choose the first number from 10 numbers, the second number from 10, you are not constrained, third number from 10, and the fourth number from 10. So that means we are going to have 10 times 10 times 10 times 10, which means we are going to have 10,000 possible combinations that we can make if we are allowed to repeat all the digits. So that was that. Do you guys understand here, or what I said so far? Because today we are building up on that, and it's very important that you understand. So just give me a thumbs up if you do. There is no in between, guys. It's either you understand or you don't, okay? Right. Okay, I see your thumbs ups. Let's go to the next one. What I introduced you to in the last lesson was the factorial notation, guys, which is that if you see 5 with an exclamation mark, to us as people who are doing pure mathematics, proudly so, that is not an exclamation mark. That we are going to refer to as the factorial sign. So meaning 5 to the people who are doing English is just 5, but to us, when we see 5 with an exclamation mark, what we see is 5 factorial. And we said 5 factorial, what it means is you will have 5 times a number which is 1 less, which is 4, times another one which is 1 less, which is 3, times another one which is 1 less, which is 2, up until we get to 1. And when we multiply all of these numbers, we find out that 5 factorial is 120. And then we made an example. We said, okay, here's 8 factorial. That is how we pronounce this. This is not 8 exaggerated. It is 8 factorial. So 8 factorial on your calculator is 8 times 1 less number, which is 7, 6, 5, 4, 3, 2, 1. Remember, I did mention we stop at 1. And when you do the multiplication, at least last time, the people who were in the session gave me 40,320. And same goes to determining 6 factorial, and so on and so on. Why is this important? It is important because in today's lesson, we are going to build up on that. But let's have a look at example number 10, which is that a 3-digit code is made up of 3, 5, and 7. And they say each digit is used only once. And they say how many different codes are possible. So this question is very easy, guys, because they said only once. So which means the first number of our code, we are going to choose it from 3 numbers. The second one, we are going to choose from 2 numbers. And the last one, thirdly, it's going to be 1 number, whatever which is left. And according to our counting principle theorem, we just need to multiply these possible outcomes. And what we get is 3 times 2 times 1. That looks like 3 factorial, which is 6. So the factorial notation, you need to familiarize yourself with it, guys. And let's have a look at example 11. So where they say the 3-digit code is made up of 3, 5, and 7. Look at the difference. The digits may be repeated, meaning we can repeat all these digits. So guess what? It means when we are deciding on what we can put on the first number, we are going to be deciding from a choice of 3 numbers. The second number, because we are allowed to repeat, so there's no number that has been excluded. We can choose from 3 numbers. The third option, same from 3 numbers, and guess what? The combinations will be 3 by 3 by 3, which will be 27. Very nice. So, hope that makes a lot of sense, guys. So let's go to example number 12, which I think was the last problem, and I left this as homework. And before we begin, I would like you guys to help me to answer these questions. And then I can do my introduction and we get up to speed with the work of today. Right. Anyone, guys? Those who attended the lesson were here. I gave you this problem, example 12. And the example reads, given the numbers 0, 1, 2, 3, 4, and 5, how many digit numbers can be formed if the first digit may not be 0 and the number may not be repeated? Okay, yeah. So let's give A shot, guys. Any volunteer in the meeting? Let's have a look at A. Let me move B to the other side for now. Let's have a look at A. So we are required to form 4 digits. So we have 1, 2, 3, 4 spaces like this. And they say to us, out of these 4 digits, the first digit may not be 0. Okay? So if the first digit may not be 0, guys, how many options do I have for the first digit?
5.
So I have 5, because if you look carefully, in total, guys, I have 6 numbers. I have 6 options in total. So now, if you think of the constraint that we are working under, you should see that our first number, we are going to choose from 5 options. And the reason why we are choosing from 5 options it is because 0 is excluded. So we are choosing the first digit from 5 options because 0 is excluded. That is why. Now that we have the first digit, which we choose from the 5 options, and they said to us, the digits may not be repeated. So the second number, from how many options am I going to be choosing what that number is going to be, guys?
5.
5. And then what about the third digit, guys? We are choosing from how many numbers?
4.
4. Why 4? Explain to the others.
It's 4 because they said you can't repeat numbers. So out of the 5 options that you had, you've already used one option, which means you have 4 more options left.
On point. And what is the last digit, guys? From how many options are we choosing from?
3.
3. So this means when they say how many 4-digit numbers can be formed, we know that what we can do is their answer is going to be 5 by 5 by 4 by 3. What is going to be the answer, guys? Is it 300? Is that the case? Let's see, 25 by 4, that's 100 by 3, 300. Did I get it correct?
Yes.
Okay, so that is the answer, guys, for A. How many 4-digit numbers can be formed? So if you like English, as we all should, you can say 300 4-digit numbers can be formed. You remember that thing where English teachers were teaching us that when you are answering a question, the way you answer it must be indicative of what the question was. It's like, for example, if they say, who is Lisiko? You should say Lisiko is, yes. Ayabonga, you can go ahead.
I'm sorry, I don't understand why there are two fives if the numbers can't be repeated.
Okay, read the question for us first.
How many four-digit numbers can be formed if the first digit may not be zero and the numbers may not be repeated?
Okay, let's pause there. So let's have a look at, we have 4 spaces there. So for the first number, we are going to choose from how many options?
5.
5. Okay, so we are going to choose from 5 numbers. Why 5 numbers?
Because there are 5 options.
There are 6 options in total. Do you see that? 0 to 5 is 6 numbers.
Oh, yes.
So why should we have a 5 there?
Because 0 is excluded.
What does that mean?
We cannot include the 0, so we have 5 options left.
Why are we not including the 0?
I'm not sure.
Okay, because they told us not to do so. How many 4-digit numbers can be formed if the first digit may not be 0? So meaning, when we are choosing the number that we can put on the first spot, they say it can't be 0. So this means for the first number, I can only choose from 5 numbers, which is 1, 2, 3, 4, and 5. Do you understand?
Yes, sir.
Right. So I've chosen one of the numbers which will sit on position 1. Now for position 2, from how many numbers am I choosing from? I've chosen 1 to sit at position 1. Now when I come to position 2, how many numbers are left that I can choose from if the total was 6?
5.
5. Yep. Then that is why we have a 5 here. Then I choose one number that will sit on this position. Now, when we go to the third position, how many numbers can we choose from?
4.
4. Why 4?
Because you can't repeat the 5.
No. So the 5, do not think of it as if we are choosing 5 to sit in that position. You understand what I'm saying?
Yes.
So think of it this way. The 5 there is not saying we have a 5. For the first one, we said we are choosing from 5 numbers, which means removing the 0 that they don't want us to choose from. Then the second position, when we decide which number should sit there, we are going to be choosing from 5 numbers because one of the numbers from the 6 has been chosen on the previous, what you would call number, which is option 1. Do you understand?
Yes.
And then when we go to number 3, the 4 here does not say we are going to put a 4, but it says we have 4 options to choose from what number should sit there because we have used the other 2 numbers. So we're only left with 4. And for this one, we'll only be left with 3 numbers to choose from on position number 4. Do you understand?
Yes, sir.
Yes. And then according to our counting principle, you multiply those options to get the total number of combinations that can be made, which is why we said 5 by 5 by 4 by 3, which gave us 300. And that's why we said 304-digit numbers can be formed. Do you understand?
Yes, sir. Thank you.
Awesome. Thank you for the question, guys. Let's go to B. Anyone to read this for us? Anyone, guys?
How many of these numbers will be divisible by 5?
Okay. Awesome. Thanks for that. So now we need to think carefully, guys. When they say how many of these numbers will be divisible by 5, we need to think carefully what that means. So let's go ahead and put in our 4 spaces. So 1, 2, 3, 4. So here's our P. Already they told us that for the first one, we can't have a 0 there. So let's think of it. But maybe a question to you guys is, what is a number that is divisible by 5?
It's a number that ends in 0 or it ends in 5.
How do you know that?
A number that's divisible by 5 is a number that is able to be divided by 5 and you get a whole number instead of decimals.
Yep, on point. Thanks for that. That is genius. So guys, what you need to note for yourself, and that makes this problem to be very easy. So a number that is divisible by 5, that is divisible by 5, ends with a 5 or a 0. This note is very important, guys, because it helps you. If you think of numbers that are divisible by 5, let me give you an example. 15, do you see it ends with a 5, 10, and we can do even 30 or 25 or 75 or whatever number that you can think of, 1,020 and so on. What you need to realize is that these numbers are ending with zeros or they are ending with 5s, guys, or there's a 5. So that pickup there is very important as part of answering our problem. So remember, guys, the first digit, they said it can be a 0. So which means we are still choosing from 5 options because that digit can't be a 0. Can be 0. But let's think of the last digit of our number. So on our 4-digit number, the last digit, we want it to be a 0 or a 5. So how many choices do we choose from for us to get the last digit? And let me stop one of you from answering the question. I'm going to say I hold it there for this one. Let's give the others a shot. And if they delay, you can jump in. So I'm looking for this last digit, guys. How many options are we going to choose from? Anyone? In the interest of time, let's open it for everyone then. You can go ahead, guys.
So I I actually have a question.
Okay, go ahead.
For the last one, I want to say you have 2 options because of the 5 and the 0. But then I'm not sure if you're allowed to repeat numbers because in the first option you've already used 5. So would you still be able to use it in the last option?
That is actually a very good one. It's a good one. So maybe we need to redo our problem. So actually, let's rethink this. Let's start from the end, because if we want to make this to be divisible by 2, we must force, not by 2, my apologies, by 5. We must force the last number. So let's start there, and you'll see how we'll modify that. So on the last digit, guys, what do we put there?
You'd put 2.
On point. So we put 2. And Mahle, why do we put 2 here? Do you understand?
No, sir, I don't understand.
Okay. So I'll need you to keep your mic unmuted. Okay. So they said that we are required to form a pin that is divisible by 5. What is a number that is divisible by 5?
Number that is divisible by 5 ends with the 5
Yeah.
or a 0.
On point. So when you look at our total number of options, we have 6 numbers here. Of these 6 numbers, how many options do we have for the last digit that could allow the number to be divisible by 5?
You
Just think about it. So we have 0 up to 5.
to 5.
And we are saying we want the last number to be divisible by 5. So when I look at 0 to 5, on the last number, how many options can I choose from so that the number is divisible by 5? Of my 6 options in total.
2 options.
Yep. So if you think carefully, it's either I put a 0 or a 5, which is why we have 2 here. So which means there's only 2 options for the last number because we want it to be divisible by 5. Do you understand?
Yes.
Right. Awesome. Thanks for that. Now that, guys, we have forced the last digit to be either a 0 or a 5, then what happens to the first number here? How many options do we have? Remember that the first number cannot be a 0. So here we need to think very carefully. Anyone, guys?
4.
4. Why are you saying 4?
You already used it for your last option.
We have already used what?
We've already used 0 and the 5 for our last slots. You only have 4 options left, I think.
Okay. Anyone else, guys? So on the last number, it's either we're going to have a 5 or a 0. Then for the first digit, how many numbers do we then choose from? Anyone, guys? Okay. So to make your life to be easy, let's maybe break this question down, guys, to this way. Let me just add a page, a couple of them, so that you have a feel of the thinking before we just write a formula. So let's make this to be maybe a bit extreme. So let's say here, we have two options. Remember, we can make a 5 or a 0 here. So let's say we put in a 0 here, guys. This means we have one option to choose from, isn't it? And then this means the first number we can choose from 5 options. And the second one we can choose from 4. And the third one we can choose from 3. Do you guys agree? If we force the last number to be 0. Do you guys agree? Give me a thumbs up if you do. We make the last digit to be equal to 0, then this is what we get. However, we know that there's another option also, equally so, 1, 2, 3, 4, where this last number can actually be 5. So what we are going to do is we are going to force it to be 5. And there's only one 5 to choose from. Agreed, guys? Right. But now that we have forced that number to be 5, making this to be one option, how many numbers do I choose the first option from? Think about it carefully, guys. The first digit, if you think carefully, because 0 is not supposed to be starting there, I am only going to choose from 4 numbers. Do you guys agree? Right. So from 4 numbers, that is what I'm going to choose from. And if you think carefully, we've used one number here and we've used another number here. That means I've used 2 numbers of the 6. So it means this one here, I'm going to choose it from 4 numbers. You guys agree? And this one, I'm going to choose it from 3. Any question, guys?
So I don't understand why the second option is also 4.
Okay. So let's move back. So for the back one, you understand that we are saying, let's force it to be 5, which means we only have one option.
Yes.
That is one number down. For the first one, we know that we have 5 numbers, but 0 is not supposed to be chosen. So hence we only choose from an option of 4 numbers. Do you understand?
Yes.
But think of it. So we've chosen one number here and another number here. How many numbers are left to choose from?
Oh, I get it now. Okay, thank you. Because you still have 4 since now you're allowed to use the 0.
Yep, now
Okay,
I'm
thank you,
choosing
sir.
from 4 numbers, and then now I'm choosing from 3 numbers. So these are the 2 possible ways that things could unfold, and you just sum the answers. Anyone, guys, who has a question here? Let me pause. Any question, guys? Let me take this one and just equate it to that and get the answer. What is the answer to this one, guys? Let's put in our multiply, multiply, multiply. So if our number ends with a 0, how many numbers are we going to get? Anyone, guys? 5 by
60.
4, that becomes 60. And then if our numbers end with a 5, how many combinations or how many numbers are we going to have?
48.
48. So it means the total number of numbers that will be divisible by 5 will be the sum of the 2. So the total will be 60 plus 48, which will be 108. So the answer to our question is that we will have 108 numbers that are divisible are divisible by that. So that are divisible by 5. You guys understand? Okay, I'm glad you do, guys. So that is one way to deal with this question. We are going to explore the other way that we could deal with this very same question. Yep. So let me leave this part for now. Let's go to what we have planned for today, and then I'll come back to doing that question in another way. But very importantly, guys, make sure that you do your homeworks. It's very important because your understanding here is solidified by what you do. So there's something that I want to introduce you to, which your teachers, they call them permutations. So let's have a look at what they are and why should we even care about them. So let's go ahead. Let's have a look at what is called permutation. So essentially for permutation, guys, all what we are looking at is we are looking at using a formula to solve much of the problems that we have been dealing with. So that is what we will be doing. We'll be using a formula to solve our problems. That is what we are going to do. So I'm going to push a couple of formulas to you. But let's start with this one, which is the formula for permutation. So the formula for permutation, guys, is as follows. Below, permutation. The formulas or the formula that we are supposed to use is equal to, we'll have n factorial divided by n minus r factorial. And this will give us the number of possible outcomes, or this will give us the number of combinations. So that is what this will give us. So it will give us the number of combinations. Essentially what we've been calculating. But we need to make sure that we understand what is what before we use this formula. So our n, very importantly, stands for the number of possible options. So it stands for the number, and you will see, stands for the number of possible options available. So in our case, this would be, you remember the case of saying we have 6 numbers and whatnot. Okay, that would be an example. And let's go and look at our R because it shows up here. Our R stands for the number of positions available. So our R stands for the number of positions available. Okay, this is what our formula states. Guys, anyone who has a question for now? Right, let me show you an example of how we use this permutation formula. So I'll go and pull an example where, let me see, a 3-digit code, how long? I want one which is no repetition. Let's take example 5, guys. which we previously did. And let's see how we are going to apply our permutation here. So we'll make it example 12. So if you look carefully, guys, the first thing that we need to understand is we need to determine what is N and what is R. And for this formula, the one that I defined here, we are going to use it when we have no repetition. Okay. When we have repetition, we are going to work slightly differently. So here, let me just say we will work when we have no repetition. And repetition seems very odd. We'll rectify it later. So when we have no repeating of anything, guys, that is the formula that we are going to use. So the first thing that we need to establish here is we are, or understand the question, which we are required to form a pin, which is 4 digits. And how many combinations can be made if the digits cannot be repeated? So the first thing which we need to understand is the N. The N stands for the number of possible options available. So remember that, guys, if we are forming a 4-digit pin, what we are looking for, we are going to get those digits from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the numbers that we are going to choose from. We are going to choose from these numbers. So now the question, guys, becomes what is N if we wanted to use this formula? If we want to use this formula, N factorial divided by N minus R all factorial. Anyone, guys? Any takes? In the interest of time, I'm just going to give you our N here is going to be 6. Okay, our N is going to be 6. And then the next thing we should ask ourselves is what is R? If we want to use that equation. And if you read R, it stands for the number of positions available. So what we are trying to do is to form a 4-digit number, 1, 2, 3, 4. So do you guys see that our R will be 4? Because we have 4 positions. Due to needing 4 digits. Do you guys understand? I see a hand from Marcia. You can go ahead.
Okay, why is our N 6?
Okay, let's go and read what N stands for. Read for us what N stands for.
Stands for the number of possible options available.
Okay. So I said N is 6. What are you saying?
10.
You are saying same.
10.
10. Why 10? Why 10?
Because there are 10 possible options available.
Yep, you are such a genius. N is supposed to be 10. Guys, please clap for them. So it means everyone else didn't see anything wrong here, guys, in the meeting. I am concerned. Everyone was saying, okay, it's 6. He chooses to have a 6 and therefore he's correct. is the teacher after all. And teachers are always correct, isn't it, guys? Teachers are never wrong. So our N is 10. Is our R correct? Timbisile. Is my R correct?
Yes, sir.
Why is it correct?
Because there are 4 positions and place.
Yep, on point. So now, guys, we can go and calculate our answer. So it means we have 10 factorial divided by 10 minus 4 factorial. So if you guys go and use your calculators, you can get the answer right. So your calculator does have a factorial option. Let me see if I can pop mine, because we use more of the same calculator. So if you look carefully, guys, where is my factorial sign on my calculator? Let me look. Let me click shift. Let me remove that. Let's do shift. Where is my factorial here? That I is for complex numbers. Oh, there you go. Okay. So I need to do, I believe, alpha mode, or is it shift? So you see factorial just below mode, guys. Let me put 10 and then shift that. Okay, so in your calculator, guys, you need to go and hold your shift. You see, I'm holding it, and then you click. Well, the problem with my calculator is that it's digital. Let's do 10. I do shift, and then I click. Well, it doesn't want me to hold, but I do shift, and I just click that. Shift. Oh, no. Yeah. So my calculator says shift, and then you will usually see on your calculator that factorial sign, guys. See that there. So just work around your calculator and make sure that you know what that sign is. Okay. So what we are going to do is go to our thingy, our note, and then open our calculator, just the side. Not so big. Let's open it here. So there's our calculator. So I'm going to go and punch that. I need you to make sure that you know how to use your calculator. So 10, and then for me, I need to do shift and then click that. There's my 10 factorial, guys. Open the bracket, 10 minus 4, and then shift. I click there, and there you go, guys. And that is the answer that I get. Do you guys understand? So that on your calculator, because it wouldn't be on scientific mode, will be, I think, 5,040. So we will have 5,040 as our answer. So we can make 5,040 different combination, guys, of which, if you look at this answer, it matches up with what we had previously, guys. Let's go to example 5 and see what we found. 5,040, guys. Are we not geniuses? Where are the thumbs ups? We are very smart. So just please make sure that you know how to use your equation, guys. So we can use our equation for that. Any question on this equation? Very importantly, it's very easy to use when there's no repetition. Then there's another one which we use when there are repetition, or when you do have a repetition of things. And that one is going to be, do we have anyone who remembers it? Okay, let me give it to you. But guys, the most important note is this one. You will use it when you do not have any repetitions. So before I jump to my planned problems, let me get in the other equation and then we jump to our problems, guys. And I'm going to leave you with a couple of homework problems. So when we have now repeated options, we have an equation that we can use. So when we have repeated options. So when we have repeated options, the equation that we can use that will allow us to be able to calculate the repeated parts. The equation will be n to the power of r, where already these have been defined, guys. N would be the number of options and r would be the positions available. This is when you have your repetition. Any question, guys? Questions for me? Questions. Right. If there's no question, guys, we are just going to look at the last bit, which is one last formula, and then we go and work out even more problems. So there's a formula that we can also use, which looks as follows. There's a formula which is n plus r minus 1 factorial divided by r factorial multiplying n minus 1 factorial. Do any of you remember this, guy? Okay, so this one I'll explain when we deal with a problem and you will see how it works. Okay, now let's jump into these problems. So wait for later. If I don't do it today, it will probably be in another lesson. So guys, let's jump into some problems. And I need someone to quickly read this for us and we ace it. So you actually know good enough to be able to deal with these problems. Anyone, guys, please read for us 1.1 and we deal with that. Or 11.1.
Given the digits 3, 4, 5, 6, 7, 8, 9, calculate how many unique 5-digit codes can be formed using the digits above. If the digits may be repeated, and if the digits may not be repeated.
On point. Thanks for that. So what we need to realize, guys, is that we are choosing from 3, 4, 5, 6, 7, 8, and 9. So this is the total number of options. So total number of choices or options. So if you look carefully, that total number is equal to 1, 2, 3, 4, 5, 6, 7. So we are choosing from 7 numbers, isn't it, guys? And for 11.1.1, what is very important is that they say to us the digit may be repeated. Note, they say digits may be repeated. So that is very important. And if you remember, we can use our equation, guys, or maybe not. But let's start going the long way. And remember that what we are looking for is a 5-digit code. So what that means is we have 5 spaces, 1, 2, 3, 4, and 5. So given that they say the digits may be repeated, guys, the first digit, from how many numbers are we choosing it from? Okay, I'll give it to you. We are going to choose from 7 numbers. And the second digit, we are going to choose from 7 numbers, 7 numbers, 7 numbers, and 7 numbers. And the reason is simple. They told us that the digits may be repeated. That is why we are choosing from 7 in every digit of the 5. And then what we know is that we obviously need to go and multiply all of these. And when you multiply these, you will see that we have 7 5s here. So it's going to be 7 to the power of 5. What is the answer, guys?
$16,807.
16,807, like this.
Yes.
On point. So we can then say that to them, 16,807 5-digit codes can be formed. That is our answer. But if you look carefully, guys, under our permutation, if you remember, I gave you a formula that was n to the power of r. That was like this, n to the power of r. So when we look at our problem, you will see that our n is equal to what, guys? 7.
7.
And our r is equal to
5.
5. So we could have used our formula to find our answer, which is 7 to the 5, which gives us the same thing, 16,807. So when they say repeated, very importantly, you refer to our formula. Okay, and this here, remember, we use it for repeated. So you guys must make sure that you do understand those notes that we wrote. So let's go to 11.1.2. So they say the digits may not be repeated. So that is the note that we need to make there. So the note is that the digits may not be repeated. And guess what? Because we are so smart and we learned from this lesson, we can say, okay, I'm going to do it in 2 ways. I remember that there's a formula that is n factorial divided by n minus r factorial. And I've established previously that n is 7 and r is 5. So it means my answer will be 7 factorial divided by 7 minus 5 factorial, 5 factorial outside. So I'm going to go to my calculator and look for the answer. So for us to get this, what we are going to do is use the calculator. Anyone, guys, who has used their calculator, please give us the answer.
2,520.
2,000.
2,520.
520, like this. Okay, so thanks for that. Are you guys in agreement with them? Awesome. So let's go to the next question. But here, someone else would have said, okay, but I'm not sure of these formulas and how they work. I'm going to go the long way. But anyway, here, our answer is that 2,520 codes can be formed. Someone else would have said, look, I prefer the long way. So that is why we're going to say another way. Another way. So someone else would have said, I just like the long way. So if I have 5 numbers like this, 1, 2, 3, 4, 5. If they don't allow me to repeat the digits, and I have 7 of them, the first number I'm going to choose from how many numbers, guys?
Seven,
Yep, I'm going to choose it from 7. And the second number?
6,
From 6, then from 5, from 4, and then from 3. Can you guys do the maths here and tell me what you get?
2,520.
2,520. Are we all guys smiling? This is beautiful, isn't it? Because there's many ways we can go around the problem, but we come back to the same answer. So if you prefer, the way of saying I'm able to make sense of it by putting the spaces, then good for you, go for it. If you now have a hang of the formulas, you can use them. Take away, use what you are comfortable with. Let's jump to the other one, guys. And let me see. Okay, so let's go ahead, guys. This is going to be a very interesting one. Anyone to read this for us?
A company uses a coding system to identify clients. Each code is made up of 2 letters and a sequence of digits. For example, AD108 or RR45789. The letters are chosen from A to R, S, and U. Letters may be repeated in the code. The digits 0 to 9 are used, but no digits may be repeated in the code. 1.1.1. How many different clients can be identified with a coding system that is made of anymore?
Okay, awesome. Thanks for that. Let's get to it, guys. So what we are going to do is we are going to look at the letters first. So 11.1, we are going to focus on the letters. So for the letters, guys, we have the letters A, D, R, S, and U. And in our problem, they say we must have 2 letters. So we are required to have 2 letters. So not many. So we can only use 2 letters. And they say we can repeat the letters. Let's have a look. The letters may be repeated. So another note we need to make, that one, very important. So note, they told us that letters may be repeated. So since we're dealing with 2 letters, guys, we are just going to have 1 and 2 because we are trying to look from the letters, how many combinations can we have? And if you observe carefully, the total number of letters that we have is 1, 2, 3, 4, 5. We have 5 letters in total. So this means, guys, the first position we are going to choose from how many letters? And the second one?
5.
Yep, so we're going to choose from 5 and 5. So we're going to have 5 and 5. So these we always multiply. And if you look careful, we'll have 25 combinations that we could make. So from the letters. So our letters are giving us 25 combinations. Done with that. Now, let's go to now the numbers or the digits. So for the digits, we know that we obviously have what you would call it, the numbers from 1 up until from 0 up to 9. So for digits, what we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So essentially what we have is 10 digits. 10 digits in total. And then we need to make a note. Are we allowed to repeat the digits? And they say no digit may be repeated. So that needs to be noted down. So I'm going to say note, no digit may be repeated. Okay, and what is very important is we are required to figure out the combination when we have 2 digits. So we are required to have 2 digits. So if you think carefully, we're going to have digit number 1, digit number 2, and we're not allowed to repeat anything. So guys, the first option we are going to choose from how many digits?
10.
10. And for the second digit, we're choosing from how many?
9.
9. So this just becomes 9 times 10, which becomes what? 90. 90 combinations. And this is for the digits. That is very important. For the digits. So someone else, guys, could have easily used our formula. You remember that one? Our favorite formula, n minus r. And you would have seen that your n here is 10 and your r is 2. So if you go and say 10 factorial divided by 10 minus 2 factorial, what is the answer, guys? What is the answer?
90.
19. Okay, so it looks like our formula works, isn't it, guys? You can go and show others at school and say, do you know that equation for permutations? And yes, it works. So we have 90 combinations. So now that we know how the letters are combined and how the digits are combined, for us to get the total number, we just multiply them. So how many different clients can be identified? We just multiply the 2. So the answer will just be, for the digits, we got 25. So we have 25 multiplied by 90. What is this going to be, guys? With that is for letters. And the 90 is for digits. What is the answer that we get?
2,250.
2,250. So essentially what we have is or how many clients can be identified. So we can say in conclusion, 2,250 clients can be identified. Do you guys understand this question? Okay, I'm glad you do. And then let's go for the next question and see what happens. Let me add a page, and I think I have 2 more questions, but I'm going to leave them as homework for you guys. You should go and do this work and you'll realize these are easy. So they say, determine the least number of digits that is required for the company to uniquely identify 700,000 clients using their coding system. So how do you think, guys, we should approach this? So they always work with 2 letters. But now what we require is that they have 700,000 clients. We're looking at that 11.2. So what we found out is that with 2 digits, with 2 letters, which they still maintain, the number of combinations that we get is 25. So we have 25 combinations. But what do we require, or what do we remember, guys? What we remember is that we have the combinations, or is that when we have the combinations of letters multiplying that of digits, what we get is the number of clients, or the number of clients that could be accommodated. So when we have the combinations, letters multiplying digits, what we get is the number of clients that can be accommodated. So that equals number of clients that can be accommodated or identified using their wording. So why is writing this important? The 2 letters they maintain, but now they are trying to figure out, if you want to accommodate 700,000 people, how many numbers should we put? So it means what we are going to have is 25 multiplied by X equals 700,000. So the X will be the combination of the digits, where X will be the combination that we get of the digits, which we want to figure out. When we multiply the numbers, how many combinations can we make? We'll work in reverse. You guys understand the thinking here? So we know the letters, they're going to give us 25 combinations. But the digits, we are not sure how many combinations they need to give us for us to get to 700,000. So we're going to figure that out and then work in reverse, because we are told that the digits are not repeated. So guys, can you please give me what the X is? So when you solve for X, it will be 700,000 divided by 25. What is the answer?
28,000.
28,000.
28,000. Now let's pause and think what the 28,000 means. X equals 28,000. Anyone who wants to tell us what the 28,000 stands for in your understanding? Remember, what wins, guys, is understanding. So the 28,000, guys, says when we when we formulate our PIN for the digits, we need to get at least 28,000. So what we are going to do to answer that, we are going to do a trial and error. Remember that X will be the combination of the digits. And remember, guys, very importantly, they said no digit may be repeated. So we must note that no digit can be repeated. So what I'm going to do is, we know that two codes or two digits, guys, as we did here, two digits, they give us 90. So two digits, we know they are not going to be enough, isn't it? So we are going to go and try three digits. So maybe let's start with two digits for your benefit. So when we do two digits, what we get is 10 times 9, which becomes 90. So, and then we will say, okay, 90 is not enough because what we need is 28. So we'll go to three digits, which means we are going to have 10 times 9 times 8. What is that, guys?
720.
720. Then we see that, okay, three digits don't work. So let's go to four digits. So for our four digits, you guys can do the calculation. 10 by 9 by 8 by 7. What is it?
5,040.
5,040, not 5,400. 5,040. So this doesn't work, guys. So we go ahead and say, okay, let's go and try five digits, which means we want to have 10 by 9, 8, 7, and 6. What is it, guys?
30,240.
30,240. Okay. So clearly, four digits will not work, guys. They will leave us at 5,000. Five digits will work because they said, what is the minimum number of digits? So five will work. If we go to six, we'll go even higher. Five will work because we require 28 and 30 is above 28. So essentially, our conclusion is that five digits are required. Do you guys understand why? Because we require 28. So 28, 30 is bigger than 28. So which means when we have 30, when you look at our total combinations, it will at least meet the 700,000 that they need. Because what we are going to have is 25 by this 30 to 40. And what is the answer, guys? So this number must be bigger than 700,000. What is it? What is it, guys?
It is 180,000.
It is what?
180,000.
25 times 30,240.
756,000.
756,000. Do you see that this, guys, is bigger than the 700 that they require? Therefore, we are happy. You see that? So that there makes us happy because it is bigger than the needed 700,000. Does it make sense, guys? So this maths is beautiful. So with that said, guys, I think let me also squeeze in this one so that maybe we conclude counting principles. So let's have a look at this question. Anyone to read this for us? And we wrap this up. Lisijo, you can go ahead. Please read this for us.
The digits 1 to 7 are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000?
Thanks for that. So this is very interesting. So what I usually do is when I encounter such problems, I make some notes. And the first note, which we need to make, is that digits may not be repeated. Digits may not be repeated. Done with that. And the second one is how many different codes are possible if and the code must be an even number greater than 5,000. So what we require is the code, that the code must be even and also greater than 5,000. Okay, these are the requirements. And also we obviously require a 4-digit code. So the first thing that I'm going to outline, guys, is what are our options when we talk of the digits. So our options are obviously 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what we have is 10 options to choose from. Okay. Oh, look, guys, they said the digits 1 to 7 may be used. No, I was ahead of myself. So this is what we can choose from. So which means we have 1, 2, 3, 4, 5, 6, 7 codes, 7 options. Okay, so let's go and think of how this is going to look, guys. So I have 1, 2, 3, 4. So they said that they require this code to be even. So what is an even number, guys? So we can start there. We can start thinking about even number because they said the code must be even. So if you remember, an even number is a number that is what? Anyone, guys? I'll give it to you. It is a number. Remember here we're working with 1 to 7. So it is a number that ends with, usually an even number is a number that can end with a 0, a 2, a 4, a 6, an 8. Yeah, these are the only numbers. 0, 2, 4, 6, 8. But when we look at our problem, we only have the 2, the 4, the 6, and the 8. We don't have the 0, guys. Do you see that? So this means that when we are now thinking about the even number, which is the last number. So here, what we require this to be even. So if we need this to be even, guys, of what we have, how many choices can we choose the last number from? Okay, so if you look carefully, it can be 4. But the way I'm going to approach this, guys, is such that if you remember last time's problem, so I'm going to have 1, 2, 3, 4, 1, 2. I'm going to split it like that. 3, 4, 2, 3, 4, 1, 2, 3, 4. I'm going to have the last one, 1, 2, 3, 4. So what I'm going to do is on the last number, I am going to force them to be certain values. So for example, if here I want this to be an even number, I can choose a 2, and then or I can choose a 4, or I can choose a 6. Actually, because we are doing up to 8, we don't have the 7. So those are the only 3. And if you think carefully, if I choose a 2, that means I only have one that can sit there. You guys understand? Right. And if you think carefully, they say the number must be greater than 5,000. So it means that for us to have something that is greater than 5,000, I need to choose the first numbers such that they are 5 or bigger. Okay. So if you think carefully, if I have chosen 2, the only numbers that are bigger than 5, it is this one, and this one. So it means I can only choose from 3 numbers. Okay. And the same goes from here. I can only choose from 3 numbers. I can only choose from 3 numbers. No, mistaken. So if we choose 4, 4 is still less. So I can still choose from 3 numbers. But for the 6, guys, when we print a 6 at the end, the first numbers, how many options do I choose from? If you think carefully, it is going to be 2. Do you understand why?
No, sir.
Because the numbers that are going to be bigger than 5,000, remember 5,000 is like this. So we have 5, 0, 0, 0. So for here, remember for us to be bigger than 5,000, I can choose from a 5, a 6, and a 7, because on the last number, I just print a 2. Okay. And then for the next one, I have a 4. So I can still choose from a 5, a 6, and a 7, because remember, I need a number that is at least bigger than 5,000. And if you look at how 5,000 is, it is 5, 0, 0, 0. So it means I can either have a 5, a 6, or a 7 so that I'm bigger than 5,000. So I can choose from 3 because I'm putting 2 on the last one. 4 here, same. But now when I get to 6 here, I can't choose from 5, 6, 7 now. I can only choose from 5 and 7. That is what makes the 2 options. Do you understand?
Yes, sir.
On point. And then now we've chosen 2 numbers and we had 7 numbers in total. So that means I'm left with 5 and a 4. I'm left with 5 and a 4. I'm left with 5 and A4. So all what I do, multiply all of these and add them. So that is what we need to do. And I will require your help, guys. So these exercises are very interesting. So for the first one, what do we get? 5 by 4, that is 20, by 3, that is 60. For the second one, what do we get, guys? That is also 60. For the third one, 5 by 4, that is 20 by 2, that is 40.
40.
Yep. So it means the number of different codes. Answer. Our answer will be 60 plus 60 plus 40, which is going to be 160.
60.
So it means our answer here, conclusion, will be that we can create 160 different codes. different codes. So that is one way to deal with these problems that seem to be complex, guys. Divide them. And this is what I really suggest, because at times these formulas, they are a bit complicated. So I would really advise that you get a feel of how we do this, and you should be okay. Do you guys understand? Right. I see a thumbs up. Happiness. So if you look carefully, we have one last question, guys, which I'm going to leave as, you guessed it right, as homework. And this, guys, brings us to the end of counting principles. Any question for myself? What is it which you guys are lacking and which was maybe not covered? Okay. There's none, guys. Let me give you a smile, because we have done counting principle and it seems to be making sense. And this brings us to the end of this section on probability, which is counting principles. Okay, guys, there's no question for me. Cheers and enjoy the remainder of your day. Bye-bye.